So we pretty much know the arithmetic operators: plus, minus, star for multiply, slash for division, and I believe we talked about two others. We talked about double slash. What does that do?
Remainder.
Close. Percent sign is remainder.
Floor division?
Yep, floor division, which means divide and round down. So along with these, like if you did this, A is equal to A plus 10, B is equal to B minus 20, stuff like that. You could rewrite those like this. A plus equals 10, B minus equals 20, like that. Those mean the same thing. This means take A, add to it, and then store it back into A. This means take B, subtract 10 from it, and store it back into B. So these are kind of shortcut ways of writing these things. The most common thing you'll see is when people are adding 1 to something. Rather than type in B is equal to B plus 1, they just say B plus equals 1. Or subtracting, follows the same kind of rule. Like instead of C is equal to C minus 1, just do C minus equals 1. Is there anything wrong in writing it like that? Absolutely not. Are you going to see me write it like this more often? Yeah, you are, because it's just less stuff to type. So I type it more quickly. Only thing is that you can't space it wrong. In this language, spaces often don't matter. You can do it like that. That's great. But if you put a space between those two things, it's no longer going to work. If you put a space between those two things, it's no longer going to work. Those guys have to be hooked up together for it to actually work. So rules of precedence, I bet we talked about that. PEMDAS, parentheses happen before exponents and stuff like that. Raise your thumb if we have. Okay, I saw one thumb. 2, awesome.
Are you playing?
Yes, I am. Alrighty. This slide may be in error for the language in which we are using, so I may skip that slide. Let's find out. What that slide is saying is that if you divide an int by another int, it's going to round it down. And in this language it doesn't. So, for us, that slide is incorrect. For other languages, like C and Java, it is not incorrect. If you divide an integer by an integer, in those languages, the result is an integer, so it is by necessity rounded down since the result can't hold a decimal point. But that's not true for us, and if we wanted it to be the case, we would use floor division. So the remainder, we've talked about remainders. 24 mod 10 means 24 divided by 10, take the remainder. So 10 goes into 24 2 times with a remainder of 4. So 24 mod 10, percent sign, that's 4. Alrighty, moving away from math. Understanding the advantages of modularization. A module, they call it a subunit of a programming problem. It's just a named block of code. It's a block of code that you give a name to so that you can go and repeat it, right? Like if you were going to tell somebody how to go to Walmart, it'd be a real drag if you had to tell them the entire list of instructions every single time. Instead, you can give them a map and then you can just say go to Walmart, right? You'd like to do it with one instruction, go to Walmart, rather than have to repeat those 10 to 20 instructions it would take every time you wanted to go to Walmart. Same thing, you don't want to have to tell somebody every time about how to drive the car, how to insert the key, back on the street and stuff like that. If you could just give a command, drive to school, that's one command. But that one command consists of a whole bunch of instructions, right? A block of instructions. I'm kind of mixing real life and programming code in that idea. Same thing for if you have a recipe for baking a cake. If you have a customer and you're a bakery business, it's just nice if they can come in and say, all right, I want a carrot cake or whatever, and then you make it for them. You don't want your customer giving you 100 instructions, right? You just want them carrot cake. So that's your name of your module. Carrot cake is your module, and then the instructions it takes to make the cake. So in more computer terms, if you have a graphics command that'll draw a flower or something on the screen, and it takes 20 commands to draw that flower, you'd rather make it so that you can just call a module called flower, and it'll draw the flower for you, rather than have to repeat those 20 instructions every single time you want a new flower on the screen. What if you want 20 flowers on it? You don't want to have those instructions copied and pasted 20 times in your code. If you can just have it in a module that you can call by one name, and then you can invoke it whenever you want. And so we probably need to do something like that in class using turtle graphics, which we haven't used yet. So to call a module is to use its name to invoke the module, causing it to execute. So modularization is when you break a large problem into modules. We're going to give it a fancy term, functional decomposition. Decomposition sounds bad. Oh, the body was decomposing. Whatever. Functional decomposition is breaking down a module, a large problem, into modules. So modularization provides abstraction. Abstraction is when you pay attention to important properties while ignoring the non-essential details. A module handles the non-essential details. Selective ignorance. Okay, we would probably have to read the book to know why they're throwing these terms at us. But the idea behind good module programming is that you don't need to know the details. And we're going to go ahead and play with the turtle graphics soon, so that we have programs that draw some pictures on the screen. And then we will see some examples of modularization. The modularization is given to us in the turtle graphics. So I'm going to pull up a page about turtle graphics, how to think like a computer scientist. Hello, little turtles. Alrighty. So here's what we're going to do. Excuse me. Go ahead and pop open idle and make a new file. File new. Save it as February 14. Happy Valentine's Day. February 14.py. Alright, so the first thing we're going to do is we need to bring these modules into our code. The modules that we're going to use are stored in a file called turtle.py. So we're going to import turtle. Now we didn't write turtle.py. It ships with Python because it's far too complex for us to just sit down and whip out whenever we want to draw pictures. Alright, then we're going to do when is equal to turtle.screen. But screen is a capital S. And it ends in a parentheses and a end parentheses. So take careful note of that capital S or else it won't compile. And for some reason this guy gave the turtle a name of Alex. Usually I like calling them after, you know, the Ninja Turtles or whatever. Leo, whatever. So Alex is equal to turtle with a capital T. So check it out. The first word turtle is lowercase, and then dot, and then the next word turtle has got an uppercase T. Just trying to save ourselves some debugging time. All right. Now, alex.forward, and if you don't like typing the whole word forward, you can abbreviate it FD. Alex.fd 50. We're going to make that turtle go 50. Then we're going to make him turn to the left. Alex.left, parentheses, 90 degrees. He's going to make a 90-degree angle. And then again, let's make them go forward. Alex.fd, just an abbreviation for forward, another 50 pixels. Then I'm going to hit a few blank lines, and I'm going to type win.mainLoop. What that does is it tells the turtle window to just hang out there until the user closes it. So that's effectively the end of our program. Alrighty, I'm going to run it and see if I have any typos. Alright, do you see what it did? It drew a line, drew a right angle turn. Let's see. I want to mess with it just a little bit. Above the commands where we're telling the turtle what to do, we're going to slow it down. So, alex.speed, we're going to set its speed to 1. That's the slowest possible speed. Now I'm going to add some spaces to these numbers like I usually do to make them easier to read, at least what I hope is easier to read. And just for grins, I'm going to change those 50s to something larger, like 250. So alex.forward 250, alex.forward 250. It doesn't really matter what you make them. It's just going to draw pictures. There we go. Whoops, 250 was a little bit too big. It kind of went off the screen. I'm going to change those to 200. All right. So if we did not have the turtle modules, it would take a long time to write a program that would draw these pictures on the screen. Because it's doing a lot. When we tell it to go left, it's actually turning that little triangular cursor and then setting everything up in its brain about how it's going to be going in a new direction. And then when you tell it to go forward, it draws a line. It keeps updating the position of that triangular cursor. So by having this turtle module available to us with these modularized functions, we can get to drawing pictures a lot more quickly than if we had to write this stuff ourselves, which would take days upon days. Here's an example of that. Let's make the turtle draw a circle. So underneath that last forward, alex.circle, and I want his circle to be 200 pixels. So alex.circle, parentheses, 200. And then run it. All right, and then he drew a circle. Kind of went off the screen, but hey, there he comes back. All right. Now it kind of hurts my brain to think about how I would program it to draw that smooth circle if I didn't have a .circle command. That'd be a lot of complicated math. Maybe you math majors would go, oh yeah, well that'd be easy. Okay, easy for you, but not easy for me. And so by having a module, a function called .circle, it makes it real easy for us to draw that. So things to know about this. Whoops. The first line loads the turtle.py file, the module called turtle. And then everything that's contained in that module, dadgummit, I keep bringing up the wrong one, is referenced by using that dot notation. You know, we've seen that dot notation on the internet, right? You know, something.apple.com, you know, or whatever, you know, search.google.com. Same kind of thing. Turtle is the name of the module, and this is the name of the function that's inside that file. And so here we create our window that the turtle draws upon. If we don't have a window for the turtle to draw upon, it won't work. That's why that's the top line in it. Then we create a turtle. We could create more than one turtle if we wanted to. Underneath our circle, I'm going to create a different turtle. I'm going to call this one Leo. Leo is equal to turtle with a lowercase t, dot turtle with an uppercase T. And he's not going to draw on top of what the other one did, so he's going to do 180 degrees so he can go the other way. So Leo dot left, I don't know why I like left more than right, 180 degrees. Let's change his color before he draws. So after Leo dot left 180, Leo dot color, it's going to be red. Let's send him forward 200. Leo dot FD, or the word forward, 200. Now eventually I'm going to get tired of it going so slowly. And I made a mistake, so I got it to crash. And the mistake was I needed to put the color red in quotes. It's actually a string. So that needed to have quotes around it. Pardon me? Yes, yes, it would take RGB values. Very good question. So I could probably use $FF0000. Don't type this, guys. This is just an experiment for you guys who know RGB. I need to speed it up. It's taking a long time to do this. Yeah. Okay. So for you guys who've done programming or web design or whatever, you can also specify your colors in RGB notation. You just put a hashtag in front of it, and then you put 6 hexadecimal values that indicate the amount of red and the amount of blue and the amount of green. Okay, I'm getting tired of everything going so slowly, so I'm going to crank the speed up to 10. That's almost the maximal speed. The max speed is if you change that to a 0, and then for some reason 0 means as fast as possible, which I guess I could do. So alex.speed is going to be 0. Make him go fast. I needed to take that hashtag out of the word red, though. Pardon me? If I want him to go fast, that's absolutely correct. So right now, the first turtle is going to be blazingly fast, and then the second one's not. So you saw that one was so fast it drew it practically before we could even blink our eyes. So we could change the background color of our window. So maybe after we sent Leo forward, WIN dot BG color, that's another function, and we're going to make this background, I don't know, silver. And then let's make Leo draw his own circle. Leo.circle, it's going to be a smaller one, so Leo.circle 100. I'm just totally making these up on the fly, but you're getting the idea of how we're controlling each turtle. There. So at a certain point, the screen turned gray. And if we move that statement up to the top, right, it would be gray the whole time it was all drawing. Instead, since I had it, down at the bottom, it waited until almost the very end to do that. So you can give the turtle the window a name by calling win.title. Don't care so much about that. If you want to see a whole list of colors, this is all the different colors we can use, but however, that doesn't give us much of a idea of what they look like. So if you go into Google and type TK, like toolkit, colors, and then follow one of the links, you'll see a page that has a whole bunch of colors somewhere. Well, I don't like that one because it doesn't actually show us the colors and just shows us some of them. So I'm going to go and follow the next link. Here we go. How about that one? Oh, come on. Yeah, that's better. The third link on my screen was better. So we can turn that turtle into a whole bunch of different colors. The first page that I saw was kind of nice because it did have the RGB values as well for the colors, whereas this one does not. I'll post a link to this in our D2L so that it's easy to spot. Turtle color chart. There. And then the page that I'm looking right now, I'll also list that as well. Introduction to turtles. All right, so we talked a little bit about loops. Now we had these turtles doing a whole bunch of stuff, but now I'm just going to comment it out because I want us to be able to add some new stuff to it without having all this stuff on the screen. And I don't remember how to do an erase screen function. But I do want to make sure that everybody's gotten a picture drawing on your screen. Who's getting typos that they need help fixing? Interesting, and I might want to reference it in the future. I don't really want to use it right now, so I'm going to comment it out. The way that I'm going to do that is I'm going to go right up to this line that says Alex is equal to turtle, and I'm going to highlight everything from top to bottom like that. You can do it with your mouse if you like. Don't erase that line that says win, but get everything else from top to bottom. Leave the main loop thing in there. And then do format comment out region. There. Now all that stuff, if I run the program, nothing will happen. Good. So we're going to illustrate loops. We're going to draw a flower on this screen. A whole bunch of circles. Something like that. Or maybe we should just start off with a square. So I'm going to declare a variable. It's going to be our counter. Side is equal to 1. Oh, I haven't created my turtle yet, have I? Okay. Leo is equal to turtle dot turtle. I need my turtle.
Quick question. What's the wing command again for?
The wing command creates the background for it to draw on. If we didn't have it there, let's comment it out and run it. Oh, it seems to be working anyways without it.
Mine didn't work. I uncapitalized the S in accident. It was something about the screen not being
Huh. Anyways, it's to control the background window. You can adjust the size of the background window. You can change its color. You can give it a title. I'm going to go ahead and undo that change I just made. Seems like I saw it just create the window anyways on the fly, but you said it didn't, so the behavior seems to be inconsistent. Alrighty, so we have our turtle here. We're going to make him execute a loop to draw a square. So while side is less than or equal to 4, because there's 4 sides in a square, go forward Leo dot FD, how big of a square do we want? 100. And then turn left or right 90 degrees. Leo dot left 90 degrees. And then we better add one to side, because if we didn't, it would be an infinite loop. Side plus equals 1, or side equals side plus 1. All right, so that's my code right now. And this main loop thing has to always be at the bottom. If you have it in the middle of the code, accidentally, then it winds up stopping at that point. Okay, so if I've done my code right, then it's going to draw a square. The square's got 90-degree angles. Cool deal, it drew a square. What if we wanted to draw a triangle? What are the angles on a perfect triangle? Good guess. Yeah, 3. Yeah, it's actually 90. It's double what you said. The way you calculate the angles required to draw a perfect polygon is 360 divided by the number of sides and the number of corners. So 360 divided by 4. Wait, I said 90. That's wrong. So what's 360 divided by 3? 120. Right, right. So it's going to have to be 120 for our triangle. So let's reset side back equal to 1. And then while side is less than or equal to 3 colon, do the same thing. Go Leo dot forward 100 and then turn them left. Or heck, we could be different and make them go right this time. Leo dot right, but not 90 degrees because that's a square, a right angle. We need to go 120. You know what 45-degree angles would draw? That'd be an octagon, like a stop sign. It'd have 8 sides. And then side plus equals 1. I'm going to put some comments now. This first code is to draw a square. This second code is to draw a triangle. Sorry, I'll bring the code back. All right. So as soon as everybody gets this working, I think we're going to move the triangle code into its own function so that we can draw a triangle just by calling the word triangle rather than having to repeat those 5 lines of code. So who's got typos that are vexing them? Okay, we're going to turn this triangle code into a module so that it can be called just with one word. The way you define, and I'm going to start using the word function everywhere the book uses the word module. Just kind of switch those in your head. When you're reading the text, you see the word module, think function. When I'm speaking and I say the word function, it's what the book calls a module. You define a function. So what the book calls modules, we will call functions. And I'll never try to trip you up like on an exam. I'm not going to say, which is the correct answer, A, module, B, function, and make you, scratch your head wondering which one, if I did something like that, I would probably say module parentheses function, so that you could pick both of them at the same time. Alrighty, so what the book calls modules, we call functions. You define a function in Python like this. def function name, parentheses in parentheses, colon. That's how you do it. And then whatever name you want to give the function, in this case it's going to be triangle, you put there. So you always have to use the def keyword. You always have to have parentheses, and you can put stuff between the parentheses to customize its behavior, but we're not going to. But we've seen this syntax a lot already, right? Like every time we call .fd or .left, we put that word left or whatever, and then we use these parentheses. The parentheses is how you invoke a function. It tells the compiler that, oh, that word that was just before it is a function name. Okay, so be a good time to save our notes. Nope, it's the 14th. Slightly odd, but although we missed Thursday, and the other class didn't miss a day. Oh, I guess they missed Monday. I was about to say, y'all are ahead of them. But y'all are that much more awesome anyways. I'm kidding. Okay, so, you see all this stuff? We need to tab it over one. Why? Because we're going to have def triangle, parentheses in parentheses with a colon. So I'd like to just tab this stuff over before we add that line. Not the main loop line, but the rest of this stuff. So highlight those lines, and then you either hit the tab key or go up to Format, Indent. And heck, we could make a function out of the square code as well. But we'll do that in a minute. Okay, so you saw that I tabbed that code over, and in front of it I'm going to do def triangle, parentheses, in parentheses, colon. So now if I want to draw a triangle, I can. Triangle. There, see, it's that easy to draw a triangle. Now maybe I'm going to make Leo turn, Leo.left 120 degrees, and he's going to draw another triangle. Then I'm going to make him turn another 120 degrees. Leo. Let me tab this up so it's at the top of the screen. Leo.left 120. And one more triangle. Like that. Now that's different than how that text, that page that we were looking at, that Hello Little Turtles page, shows you how to write functions that involve turtles. A little bit different. I'm not going to bother explaining why. But if you go and you look at that page very carefully and you notice something different in it, well, their method works fine for what they're doing, and my method works fine for this. Their method is a little more correct, but I'm keeping mine a little simpler. Simple is good the first time you see it. All right, I'm going to run it. And it blew up. I made a mistake. Wonder what my mistake was. Triangle takes 0 positional arguments, but 1 was given. Okay, why did I put that 120 in the word triangle? Our triangle function does not accept any arguments. So that was wrong. The left command takes an argument, but ours doesn't. If it was supposed to take an argument, I would have defined a parameter up here. But I didn't, so I need to take that last 120 out. That was my error. Put a comment here. Remove the 120. You don't need to put that comment there. That's just for reference if you're trying to figure out the change that I just made. All right. Kind of cool. If we did this right, we could probably draw a triforce. Maybe if we made it turn right angles rather than left. I'm kind of tired of that square being there messing up our drawing. We're going to turn the square into its own function as well. Do the same thing that I did to the triangle code to the square code. tab it over and add a new line that says DEF square above it. And I want you to do that on your own. I'll do it in a minute, but turn this square code into a function as well. Highlight it, tab it, and add the DEF on top. Alrighty, so if I'm going to do that, what's the line? Well, let me tab it all over first. The tab key didn't work for me. There, it did that time. But you can always do format indent. Okay, and what did I need to put in front of it? What's the top line of that function? Somebody read it out to me. Yeah, DEF, and then what's the next word? Yeah, square, parentheses, in parentheses, colon. Alrighty. Now that I've defined that function, it's not going to draw a square when I run it. Why? Because I define the function, but I never actually call it down here. It's like writing a recipe. You've written a recipe book. You just added a new page to the recipe book, but you don't give anybody any instructions to actually bake the cake, right? So unless we come down here and we actually put a call to square, it's not going to draw a square. That's okay. Right now I'm really loving my triangles, so I don't mind it not drawing that square. Looks like a nuclear fallout symbol. Yeah. Now there's a command called fill, which will actually fill the shape that you just drew, the square or the triangle or whatever. Let's modify our triangle function so that it fills it. So I'm going to add 2 lines. You don't have to add these little comments. I'm just kind of preparing you for where they're going to go. I'm going to add a line there, and I'm going to add a line there, right? Before the while code, and we're back inside the triangle module, and after the while code. So before the while statement, I'm going to do this. Leo.beginFill, parentheses, end parentheses. So I just added this line. Then, if you have to do a begin fill, guess what the next command is? You could think either stop, but I think it's end. So leo.endFill, parentheses, end parentheses. So those are the 2 new lines of code. And let's see if I got it right. No, I didn't. Alrighty, so let me go research how to actually do it. Is it in here? No, alrighty. Whenever you're stuck, just type in Python, turtle, and then what you're trying to do. In this case, I'm trying to do a fill. Oh, it's begin underscore fill. What do you know? Alrighty. I can cope. I need to change that begin fill to begin underscore fill. And I need to change that end fill to end underscore fill. So I just changed those twice. Change those lines twice. And really, you don't have to add the comments that I'm making. I'm just trying to highlight the lines because not everybody's looking at the screen every time I make a change.
Could we give it a color?
You can give it a color. The way you give it a color is when you define your turtle, when you give it a .color command, you give it 2 parameters rather than just 1. So very good point. All right, so it's doing that. That's pretty cool. And just like you asked, we can set the color of the turtle, and we can actually change it so that it's got a fill color that's different than the draw color. So let's do that. Before we draw our first triangle, because I want all three triangles to be the same color. Leo.color, and I'm feeling a blue triangle with cyan filling, or yellow. You could do, black and green or whatever. All right, so I just added this line, and I'm going to remove these comments here. I'm pretty sure that we're all together. If we're stuck, always please stop me. Alrighty. So now it should draw it with blue ink, but then when it does the fill, it ought to fill it with yellow. That's what the second parameter did. If I didn't have a second parameter, it would just be the same as the first. Here we go.
Mine's not doing a color fill. Is it because I have a window background? Maybe?
Yeah, we can add that window background by issuing a command against the window, just like we did here. You want to change the BG color to the background color to something else, you type win.bg color and give it a color.
Because I'm not getting a color fill in my triangle. I got red and then comma yellow.
All right, let me come look. That sounds interesting. Call does have to have parentheses after it. And it'll take you a while to recognize what's a function call. But things like going forward or going left or whatever, begin fill and end fill are both functions as well. So if you left the parentheses off, it's kind of weird that Python doesn't consider that an error, but it doesn't work. So it's no longer filling because I took the, the parentheses off. I will undo that change. All right, so we drew a three-sided triangle. What if we wanted to make it so that if we started drawing squares, we could control the size of it, right? Not just 100. We're going to make some modifications to our square function before we call it, so that it can draw squares of different size. Which line here of code, out of all of these lines of code, dictates the length of each side of the square?
The side equals 1.
Nope, that's where it starts counting the number. I didn't ask the question correctly. If you wanted to increase or decrease the size of the square, what line of code would you change? It'd be that one right there, right? Because right now it's got side lengths of 100 pixels. What if you wanted it to be 50? You'd change that to 50. What if you wanted to be able to control it with a variable? Let's do that. I'm just going to call it SL for side length. And why did I type it in caps? Just because L's and 1's look very similar. So I thought it'd be easier to use caps. Now that's a syntax error all of a sudden because I haven't defined what SL is. So up here at the top, I'd better define what SL is. If I made it 100, then it's going to draw the same size square as I did before. But I could change it. I can make it 50 or 200. All right, before we get going on anything, let's just call our square function. Make sure that worked. So I added a line here. And Python is a lot more flexible about where you give function calls. Some languages make you define all your functions at the top of the code, and then you call them down at the bottom. Python's pretty slack in that. That's why I'm able to put a call right here between these function definitions. Why am I doing it that way? So I don't have to scroll up and down so much. So those are the three lines I added. SL is equal to 100. Then I changed this one to Leo.forward, parentheses SL. And then I actually had to call square so it would draw it. And it drew a square. Drew a great big one. Well, not a big one. The same size as we've been seeing. What if we wanted it to be larger? I would change that line, right? I would change SL. The side length is now going to be 200 rather than 100. And this is ruining our Triforce radiation symbol kind of thing, but that looks okay. So you see that by changing that line. But what if I wanted to be able to invoke the square function 3 times with 3 different sizes? I would need to pass that in as a parameter. I would need to have a parameter defined here, and I would need to pass in a value here. So like if I wanted to draw 3 squares, here's what I would like to be able to do. Draw me a square of 100. I changed that line, I added the 100 to it, and then draw me another square of 200. Now this isn't going to work yet because I have to actually change the function code as well, the DEF. And then square of 300. I'd like for that to work, although 300 is too big for the screen, honestly. Maybe I should make it 100, 150, 200. That's not too big to the screen. Okay, so the problem is I'm passing in these numbers that you put inside the parentheses when you call a function are called arguments. So when you call a function like this, that's called invoking, that's the fancy word, or calling, that's the cool word, you know, the function. If you put a value, one or more value, between the parentheses when you call the function, that is called an argument. And the function itself, the function def itself, has to have a parameter between the parentheses to catch that argument, or to receive, to accept the argument. So if you were going to do that, it might look something like this. DEF, I'm just going to make up a function name, ABC, and then you might have a parameter called X, and then it does something, whatever it's going to do something. Now this is not actually Python code. Don't be typing it in unless you're taking notes. And then when you called it, you might say ABC 100. So here, X is the parameter, and here 100 is the argument that fills the parameter. That sets the parameter. So, I don't know why it's giving me this warning, but whatever. Every time I save it. I need to, since I want to pass these arguments in, square needs to accept a parameter. So I'm just going to put there, SL there. But I better not have this line of code anymore, because if I had that line there, it would always draw 200 anyways, no matter what was passed in. Because it's like you're saying, go to, you know, Walmart, but then you set the destination to Target. So no matter where you told it to go, it would always be changing its destination to Target. So I'm going to I'm going to comment that line out. That SL is equal to 200. Later I may delete it. You don't want to leave too much commented code in your code, because it makes it harder to read after a while. And there we go. We get our 3 triangles. Excuse me, squares. We could do the same with the triangle function if we wanted to. As a matter of fact, that'd be pretty cool. I want you to take a stab at modifying the triangle function to accept a parameter SL. So I'm going to put SL here inside the triangle. So add SL. Now make the changes necessary for that to work. It's a little thought problem, and then I'll show you the answer in a minute. So the first thing I had to do is to add that there. Now what's the next thing? I know a couple of y'all have this working. So what line of code do I have to change in the triangle function for it to actually use that SL parameter?
The forward.
Right, because we want that to be different every time, right? Not just 100. So I need to change that 100 to SL on Leo.forward. So change 100 to SL. You don't have to put that comment. SL. So that's the second change I had to make. But that's not enough. If I run it, I'm going to get an error. I'll show you the error, and then I'll bring the code back. All right, it blows up. It does give you a line number telling you where the error occurred. Unfortunately. Now, you may have seen some programming environments that list line numbers out down the side. The guy who programmed idle apparently didn't see fit to add the line numbers. But you can still get them, right? But it's right down here at the bottom. It says line 39. That's because my cursor somewhere is on 39. And if I move my cursor up and down, it changes the line number down here. So if the error message said line 53, I would just have to move my cursor up and down until I saw that it was on line 53, and then I'd start scoping it out. So if I've made that change and that change, I need to change a couple of more lines of code. What are those lines of code?
The triangles that have no,
Right, I have to change these calls to triangle because they're expecting an argument to fill that parameter. And we don't have them. So I'm going to make the first one maybe 30, the next one to be 60, and the third one to be 90. So I changed that line. I changed it to 30. I changed the next one. And then I changed this last line to a 90. Now it ought to work. Cool deal. Alrighty, we need to do another homework assignment. I apologize if I haven't graded some of your homework assignments. The flu really knocked me for a loop. So I will get all of those done post-haste. Post-haste meaning by tomorrow, if at all possible. But I need to give you all a new homework assignment, but I'll try to make sure that the time is generous to account for the fact that not all of your homeworks have been graded. Firstly, I want to make sure that you all got the different size triangles drawing down. Anybody got syntax errors that they need to work on? Be right back there for y'all. Oh, look at the line above it. Is there something wrong with the line above it? Isn't that annoying that it doesn't highlight the right line? Yep. All right, what's going on is although we pass in a value, it's still always drawing 100. But if you wanted to change the size, how far it went forward, you would remove that 100 and move it in place of the parameter you were passing in. So just delete the 100 and make that SL instead. Nah, 120 is still appropriate for triangles. because we were trying to move the turtle called Leo, and we didn't have a turtle called Leo anymore. So I gave it a shot. Cool. Alrighty, I'm going to talk about the homework, guys, and then I'll get back to you. Not that you're not important, but I need to get this. Hopefully, you can wait, 5 minutes after class if we don't quite do it. Okay, so we have done assignments where you ask for like one value. There is a formula called BMI, which stands for body mass index. And the idea behind body mass index is that the input for it is pounds and then inches. So you're going to ask the user for pounds, and then ask the user, and when I say ask, you're going to use an input statement, user for inches, and then calculate BMI. And the formula for BMI is, like I haven't memorized. Okay, BMI formula in inches. So there it is. Pounds divided by inches times 703. We can do that. So the formula for BMI is BMI equals pounds divided by inches. And if you're a math major, you probably see that the same thing as doing divided by inches squared times 703. Let me make sure that I got that 703 right. Yep. So what the program is supposed to do is input, ask the user for pounds, ask the user for inches, and the output is supposed to be the BMI. So these are the instructions. I want you to turn that into good pseudocode or a good flow chart. And since I haven't graded everybody's pseudocode or flowchart yet, then I'm going to give an extra half a week on this so that we can talk about it on Tuesday if we need to. But that's the homework for today. Homework, write a flowchart, draw a flowchart, or pseudocode that solves the following task. Makes sense? You ask the user for two numbers, you calculate the BMI, and then you output it. Now my steps here aren't in exactly the right order, right? Because what would you do first before you output the BMI? You got to calculate it first. You can't output anything that you haven't already calculated. So that step would really, need to be above the output the BMI. But I'm going to leave it like that just as a little bit of a mystery. That's the homework. I'll post it as a Dropbox. Let's make a Dropbox for our turtle code, and we will call our class done. Are we on D or E? E. Alrighty guys, if you refresh your Dropbox, there's an in-class E. Just give me your turtle code, your February 14 code, and we're done. And let me bring the turtle code back up, and I'll help those who didn't get quite to finish. Alrighty, any questions? If not, I'll see y'all Thursday. Is today only Tuesday?
Wednesday.
Today's Wednesday. Yeah. Sorry, my brain's broken. So I'll see y'all Monday.